Alright, so the question here is to find the vertices and foci of the following hyperbola. And the equation is x squared divided by 144 minus y squared divided by 25 is equal to 1. Now first things first, we know this is hyperbola because of the minus sign here. Right? So we can say that the coefficient of x squared is positive, and in this case the coefficient of y squared is negative. And that actually makes a big difference, right? Okay. So we know that with these conic sections, right, there's an a term, there's a b term, and there's a c term. Okay. So for a hyperbola then, how do you know which one is which? Okay. So remember, this is something you're going to have to remember, okay? So in a hyperbola, okay, the first term here, you see how the coefficient of x squared is positive, right? So that means that the term underneath that, right, that's going to be always a squared. Okay? So you see how here y squared is negative? So the denominator of that term is always going to be b squared. Okay? So here we can determine that a squared, right? A squared is 144, so okay, now we know that a is equal to 12. Similarly, we know that b squared is equal to 25, so that means that b is equal to 5. Okay? So how about c then? Okay, so in a hyperbola, the relationship between a, b, and c is c squared is equal to a squared plus b squared. Now remember, this is different than for an ellipse. Okay? So here we get c squared is equal to 144 plus 25, right, which equals 169. So the square root of that, right, c is going to be the square root of 169, which is 13. Now don't forget either, right, a is the distance from the center to each vertex, and c is the distance from the center to each foci. Okay. Now we don't need to specifically graph this guy, okay, but let's just give it a shot here. Okay, so now I guess we got to figure out now, right? How do these hyperbola open, right? Do they open left to right, or do they open up and down? Okay. And we determine that also by what term comes first, right? So we notice here that the x squared term is positive, the y squared term is negative. Okay? So because the x squared term is positive here, that means that the transverse axis or the main axis will be horizontal. Okay? So these hyperbola are going to open left to right because of this the first term, right, which is x squared. Okay? So because a is equal to 12, right, that means we're going to go 12 units to the right and 12 units to the left. I'm just going to eyeball it here. Okay, and these are where the vertices are. Okay? Once again, these hyperbola are going to open left to right. Now B, okay, B represents the other distance, right? So as we go up and down in this case, right, so we're going to go 5 units up. Right? I'm just going to eyeball this. Once again, 5 units down. Okay? So we can see here that we're going to draw this little box, right? This little box. And what that means is, or the reason why we need the box is because that's going to give us our asymptotes, right? So the asymptotes are going to go through the center, and also it's going to go through each opposite end of the box here. Okay. And then finally we can draw our hyperbola, right? The hyperbola are going to follow the asymptotes, touch the vertex, right, and follow the asymptote on the other way, right? So I'm not going to call these a sideways U, okay? But this is what this hyperbola is going to look like. And where are the foci then? The foci are going to be 13 units away from the center, okay, along the major axis. Okay, so what can we conclude then? Okay, the vertices, what are the coordinates of the vertices here? The vertices are going to be at 12, 0, and negative 12, 0. And what about the foci then? Right, the foci are going to be at 13, 0 and negative 13, 0.